In the last class, we have studied about some basic concepts regarding coordinate geometry. Now, we are going to study about some important properties regarding the basic geometric shape, that is straight lines. To study angle of inclination, it is usually represented as theta. Angle of inclination is the angle made by the line with the positive direction of the x-axis. Very important, the term positive direction of the x-axis. For to find the angle of inclination, keep these points in memory. The first point is that it should be, as per the definition, it should be the measure above the x-axis. Measure above the x-axis is the first point. Measure above the x-axis only can be considered for the angle of inclination. The second point is, it is measured from the positive direction of the x-axis, from the positive direction of the x-axis up to the right of the line, up to the right of the line. It is measured from the positive direction of x-axis up to the right of the line. And the third condition is that it should measure in the anti-clockwise direction. Measure in the anti-clockwise direction. These 3 points you need to remember for to find the angle of inclination of a line. Let us see how the angle of inclination in each case. Consider the figure 1. Here, for this line L1, the angle of inclination is the angle above the x-axis, that is the first condition, measured from the positive direction of x-axis. This is the positive direction of x-axis. OX is the positive direction of the x-axis. So, measured from the positive direction of x-axis up to the right of the line. This much only. This represents the angle of inclination. It is usually represented with a theta, angle of inclination theta in the case 1. But come to case 2. Case 2 is the line L1 actually lies in the second quadrant, second and fourth quadrant in this way. For to find the angle of inclination, you need to consider the angle above the x-axis only. Then, measured from the positive direction of x-axis up to the right of the line in the anti-clockwise direction. So, this much will be. And come with the third case. So, this can be marked as theta in this case. The angle of inclination theta in the second figure. So, in the second figure, angle of inclination is the angle from the positive direction of the x-axis up to the right of the line, this much. And come with case 3. In case 3, you may feel that the line passes through the third quadrant, hence we can take the angle of inclination this way. No. Angle of inclination, the measure should be above the x-axis. You need to consider above the x-axis, measured from the positive direction of x-axis up to the right of the line. So, this much will be the angle of inclination in the third case. This is the angle of inclination theta. Anyway, it is sure that the angle of inclination always we need to consider it is the measure above the x-axis. Maximum angle can be up to 180 degree only. Starting from this point up to 180 only, it can be maximum as it is the measure above the x-axis. From this, it is clear that the angle of inclination theta lies between 0 degree and 180 degree. Maximum 180 it can happen. That is, if it starts from this point up to a full 180 degree rotation, the maximum can be 180 degree and the minimum will be 0 degree. A new concept, the slope of a line M. Slope of a line is usually denoted by M. It has a connection with the angle of inclination theta. If theta is the angle of inclination of a line L, then tan theta is called the slope of the line. If a line is having angle of inclination is theta, then its tangent value is the slope of the line. It is usually denoted by M. M equal to tan theta. Important formula. Again, if theta is the angle of inclination of a line L, then tan theta is called the slope of the line denoted by M. Consider the first figure. Here, Suppose that the line coincides with the x-axis. Your line L coincides with the x-axis. Coincides with the x-axis means it falls on the x-axis. In such a case, can you say what about the angle of inclination? Angle of inclination means angle from the positive direction of x-axis up to the right of the line that you can't mark here. So the angle of inclination theta here is 0 degree. If angle of inclination theta equal to 0, then what about the slope of the line? Therefore, the slope of the line m equal to tan theta, which is tan 0. What is the value of tan 0? 0. So, if a line coincides with the x-axis, its slope m equal to 0. Consider the second case. If a line is parallel to the x-axis, then also the angle made by the line with the positive direction of the x-axis, that is 0. If a line is parallel to the x-axis, then also the angle of inclination theta is 0. So, in such a case also, the slope m equals tan 0 equal to 0. Thus, if a line falls on the x-axis or a line is parallel to the x-axis, then its angle will be 0 and hence the slope also is 0. Consider the third figure. If a line is perpendicular to the x-axis, if this is the x-axis, this is the y-axis, the line is perpendicular to the x-axis, or you can say that if the line is parallel to the y-axis, in both the cases, the angle is 90 degree. If a line falls on the y-axis, then also the angle will be 90 degree. Angle made by the line with the positive direction of x-axis in the anti-clockwise direction up to the right of the line, that is 90 degree here. Here theta equals 90 degree. If theta is 90 degree, then what about the slope m? Hence the slope m equal to tan 90, that is non-2s. What is tan 90? Tan 90 is not defined. So, if a line is perpendicular to the x-axis, then it has no slope. So, slope means that the steepness of the line above the x-axis, like this, steepness above the x-axis. So, when it is perpendicular, it has no steepness, or you can say that you can't define about the slope of the line. Come with the last case in which the line falls. Suppose the line falls on the negative direction of the x-axis. The line falls in the negative direction of the x-axis. Of x-axis up to the right of the line. This much will be the angle theta. Here the angle theta is 180 degree. So in this case the angle theta is 180 degree, or you can say that the slope m equals tan 180 degree non for us 0. Here also the slope is 0. Hence the maximum angle can be up to 180 degree and the minimum can be 0 degree. Why? Because we can measure the angle of inclination which are above the x-axis. The angle above the x-axis represents the angle of inclination. So, angle of inclination has a connection with the slope. If theta is the angle of inclination, then its slope is tan theta. Consider a question here with as an example. Suppose that you are given with the angle theta of a line as 45 degree. You want to find the slope m. So, here slope m equals tan theta, which is tan 45. You know the value of tan 45 as 1. So, the slope of this line is 1. Consider that at another figure in which let the angle of inclination theta from the positive direction up to the right of the line. The angle of inclination theta is given to us 135 degree. In this case, the slope m equal to, the formula is tan theta, which is tan 135 degree. How we can find tan 135? Tan 135 equals tan 180 minus 45 is 135. But what about tan 180 minus theta? Tan 180 minus theta is tan theta itself, but 180 minus theta lies in the second quadrant. Hence, in the second quadrant, tan is negative. So, the value is minus tan 45. Therefore, the slope m equals minus 1. You can do a problem. Find the slope of the line whose inclination is 60 degree. We need to find the slope of a line. The inclination is given as 60 degree. Here, the angle of inclination theta equal to 60 degree. Here, theta equals 60 degree. We are asked to find the slope m. M equals tan theta equals tan 60. Tan 60 equals root 3 is the answer. Now we are going to study a very important result. Slope of a line when 2 points in it are given. If a line is having inclination theta, then the slope will be equal to tan theta. Now we are going to study if in a line you are given with 2 points as p x1 y1 and q x2 y2. For to find the slope of a line having 2 coordinates x1 y1, let p x1 y1 and q x2 y2 be any 2 points in this line. Be any 2 points in the line L. In the line L. P x1 y1 and q x2 y2 be any 2 points in the line L. If theta is the angle of inclination of the line L, if theta is the angle of inclination of the line L, then the slope m of the line will be given by m equals, remember the formula, y2 minus y1 divided by x2 minus x1. This is the formula for to find the slope of a line when the coordinates of 2 points in the line are given. Now I need to study the derivation, but I will show you how we can arrive at this result. Consider the 2 points P and Q in this line. P is having coordinate x1, y1. If P is having coordinate x1, y1, you know that the x coordinate is x1. X coordinate means from O, the origin O, up to this point. This much is x1. And this coordinate is y1. So this distance is y1. This angle is theta, remember that. And the same way, Q, the point is having coordinates x2, y2. Means that from O up to this much it will be x2. And the total height, this much will be y2. Now if I join these two, or if I draw a perpendicular to this line, let it be R. Then clearly you know that if this angle is theta, as these two lines are parallel, this also will be theta. Corresponding angles are equal. Now if you consider this right triangle alone, you can find tan theta. Here tan theta equal to opposite side by adjacent side. Opposite by adjacent. But in triangle PQR, tan theta equal to, for the triangle PQR, which is the opposite side QR, by which is the adjacent side PR. Tan theta equals QR by PR. If you can find the value of QR and PR, you can arrive at the result. What is QR? QR means this much distance. From the total height y2, if you subtract this y1, actually this y1 comes here also, y1. So from the total y2, if you subtract y1, it will be QR. So QR equals, from the total y2, you need to subtract y1 by PR, this much length. This much length equal to O, that is from the origin up to this much. So this much length minus this one. So you will get PR. That is from O up to, let it be M and this be N. From O up to M, the value is x2. From O up to N, the value is x1. So from x2 minus x1 gives the distance PR. So distance PR is x2 minus x1. If P and Q are 2 points in this line, then the slope M can be found out by using the formula y2 minus y1 by x2 minus x1. Remember this. This formula is true for both acute and obtuse angles. This formula is applicable is for both acute and obtuse angle. if the angle of inclination theta is either acute or obtuse, whatever it may be, this formula you can use for to find the slope of the line. So slope of a line when 2 points P x1 y1 and Q x2 y2 are given for you, the slope can be found out by using the formula m equals y2 minus y1 divided by x2 minus x1. Another question. Find the slope of a line joining the points A, 1, 2 and B, 3, minus 4. You are given with a line in which find the slope of a line joining the points A, 1, 2 and B, 3, minus 4. So the second formula you need to apply when the coordinate of 2 points of the line are given. The first coordinate you can take it as x1, y1 and the second one you can take it as x2, y2. Let A1, 2 be the point x1, y1 and B3 minus 4 be the point x2, y2. If the coordinates of 2 points x1, y1 and x2, y2 are given for you, therefore the slope m equals, what is the formula? Slope m equals y2 minus y1 divided by x2 minus x1. That is the difference in the y coordinates by difference in the h coordinate. Y2 minus y1 divided by x2 minus x1 equals, what is y2? Y2 is minus 4 minus, what is y1? Y1 is 2 divided by x2 minus x1. Y2 minus y1 is minus 4 minus 2 divided by x2 minus x1. x2 is 3 minus x1 is 1. 3 minus 1. So equals minus 6 by 2, which is minus 3 is the answer. From this you can say that here the slope m equals minus 3 means the slope can be, m can be positive, the slope can be negative or the slope can be 0. 3 conditions are possible for a slope to be. So don't worry when a slope comes as a negative value. Come with another question. Find the slope of a line which makes an angle of 30 degree with the positive direction of y-axis. Remember the question is positive direction of y-axis, not positive direction of x-axis. Measured in the anti-clockwise direction. You are asked to find the slope of a line L which makes an angle of 30 degree with the positive direction of y-axis. This is the positive direction of y-axis. So the line makes an angle of 30 degree with the positive direction of y-axis in the anti-clockwise direction. But you are asked to find the slope of the line. For to have the slope of a line, you need to have the angle of inclination theta starting from the positive direction of the x-axis up to the right of the line you need to have. So let theta be the angle of inclination of the line L. Angle of inclination of the line L. Can you say what the value of theta here? Theta equals from the positive direction of x-axis up to the y-axis, you know that this angle will be 90 degree plus this 30. So the angle of inclination theta here equals total from the positive direction of x-axis up to this right of the line, it will be 90 plus 30. 90 plus 30 equals 120 degree is the angle of inclination here. Here theta equals 90 degree plus 30 degree, which is 120 degree. If you are known with the value of theta, you can find the slope. Therefore, the slope m equal to tan theta. This is the first formula. This one the second formula. So m equals tan theta when the angle of inclination is given for you equals tan. What the value of theta here? 120 degree. How we can find tan 120? 120 can be found out by using the formula 180 minus 60 is 120. 180 minus 60 is 120. But what about 180 minus 60? 180 minus 60 comes in second quadrant. In second quadrant, tan is negative. So minus tan 60 you need to consider equals minus What is the value of tan 60? Root 3. So minus root 3 is the value. Therefore, to find the slope of a line, two cases may be either the angle of inclination theta is given, you can use the formula m equals tan of that angle, tan theta, and if 2 points having coordinates x1, y1 and x2, y2 is given, means that if the line passes through any 2 points, then the formula for the slope is m equals the difference of the y coordinates y2 minus y1 divided by x2 minus x1. Find the slope of a line whose inclination is, first question 30 degree, second question 150 degree. At another question, find the slope of a line passing through 3, minus 2 and minus 1, 4. Third question, find the value of x. If slope of the line joining the points minus 8, 11 and 2x is minus 4 by 3, you are given with the slope, you need to find the value of x in this coordinate. Try this. Come with another question. Find the slope of a line which passes through the origin and the midpoint of the line segment joining the points P0 minus 4 and B80. As the angle of inclination theta is not given in the question, you are sure that you need to apply the formula 2 to find the slope of a line. We can read the question again. Find the slope of a line. You need to find the slope of a line M which passes through the origin. The line passes through the origin means that the first point is known for you. That is, we can take it as x1, y1. So, this is the origin having coordinate 0, 0. So, your x1, y1 is known for you. The first point is known for you 0, 0. As the line passes through the origin. You know that x1, y1 and x2, y2 are the 2 points through which the line passes for to apply formula 2. And the midpoint of the line segment joining the points. The line segment joining the points P0 minus 4. X value 0, y value minus 4. This is the point P. This is the point P. 0 minus 4. And 8, 0, B. X value 8, y value 0. So this is the point B, 8, 0. I am going to join these two for to get the line segment PB. This is the line segment PB. But our required line passes through the midpoint of the line segment joining these 2 points. So the required line passes through the midpoint of the line segment joining these 2 points. So I need to find the midpoint. Let M be the midpoint of this line. Let M be the midpoint of PB. Let M be the midpoint of PB. If M is the midpoint, you know how to find the coordinate of the point M by using the midpoint formula. Therefore, coordinate of M is, you can apply midpoint formula, coordinate of M is equal to x1 plus x2 by 2, that is 0 plus 8 by 2, comma, y1 plus y2 by 2, that is minus 4 plus 0 by 2. This is the coordinate of the point M. Why? Because M is the midpoint of PB. Applying midpoint formula, this you can take it as x1, y1, and this, if you want, you can take it as x2, y2. So, midpoint formula states that x1 plus x2 by 2, comma, y1 plus y2 by 2. Therefore, coordinate of M equals, therefore, the point M equals 8 by 2 is 4, minus 4 by 2 is minus 2. The coordinate of M obtained for M is 4 minus 2. Now, our required line passes through. Again, we can read the question. Find the slope of the line which passes through the origin and the midpoint of the line segment joining the point. Now, this is the required line L which passes through the origin and the midpoint of this line segment. Now, the line L passes through 2 points x1, y1 and x2, y2. This I am going to mark it as x1, y1 again, and this one as x2, y2 again. If you want, you can mark it as x3y3 and x4y4. Therefore, required line L passes through. Required line L passes through the points. The first point is 0, 0, the origin, and the second point is the midpoint of the line segment joining the points M, that is M4 minus 2. The line segment required line passes through O, 0, 0 and M4 minus 2. Now you know how to find the slope of the line L. Therefore, slope of the line L equals, the formula is y2 minus y1 by x2 minus x1 when two coordinates are known for you, which is equal to y2 minus y1. The required line passes through these two points. So y2 minus y1 is minus 2 minus 0 divided by x2 minus x1, 4 minus 0. 4 minus 0 equals minus 2 by 4 equals minus 1 by 2. Therefore, slope of the line is minus 1 by 2. Now we are going to study about the condition for parallelism and perpendicularity of lines in terms of the slope. Consider two lines L1 and L2. We are going to study two separate cases. What will happen for the slope when L1 and L2 are parallel and when L1 and L2 are perpendicular? Consider two lines L1 and L2. Let their angle of inclination be theta 1 and theta 2 respectively. Let L1 parallel to L2 and let angle of inclination be angle of inclination of L1 and L2 be theta 1 and theta 2 respectively. Also, let slope of the line L1 equals M1 and slope of the line L2 equal to M2. Looking at the figure, we can see that clearly theta 1 equal to theta 2. Why? Because these two lines are given as parallel, but theta 1 and theta 2 are the corresponding angles. Clearly, theta 1 equal to theta 2. The reason they are corresponding angles. If theta 1 equal to theta 2, what happens to tan theta 1 and tan theta 2? They are also equal. Tangent of the same angle. Theta 1 and theta 2 are same angles. So their tangent values also will be same. What about tan theta 1? Tan theta 1 is actually the slope of the first line L1 that I am going to represent as M1. Slope of the first line L1 equal to M1 and tan theta 2 equal to M2. From this you can say that if two lines L1 and L2 are parallel, then if and only if, that is both the directions it is true, their slopes will be equal. Means that if L1 is parallel to L2, then M1 equal to M2. And the same way, if the slopes are equal, then the lines are parallel. Very important condition. What happens when the lines are perpendicular? Suppose that L1 and L2 are two lines in which they are perpendicular to each other. If they are perpendicular to each other, what will happen for their slope? Let the angle of inclination of the line L1 be theta 1 and the angle of inclination of the line L2 be theta 2. Let the angle of inclination of the line L1 and L2 be theta 1 and theta 2 respectively. L1 has the angle of inclination from the positive direction of x-axis up to the right of the line, that is theta 1, and the slope of the angle of inclination of L2 is theta 2. Also, let slope of the line L1 equal to M1 and slope of the line L2 equal to M2. I am going to suppose that their slopes are M1 and M2. Clearly, angle AOB equal to 90 degree. Why? Angle AOB equal to 90 degree. Why? Because if this is 90 degree, angle AOB is the vertically opposite angle, that also will be 90 degree. Vertically opposite angle. Now, I am going to draw the triangle AOB along separately here. The triangle AOB here like this. AOB. At the corner A, you need to mark the angle theta 1. Here at O, it is the vertically opposite angle, that is 90. And at the point B outside or the exterior to it, the angle is theta 2. Now, we are known that in a triangle AOB, if there is an exterior angle, then the exterior angle theta 2 must be equal to the sum of the interior opposite angles, equals theta 1 plus what is the opposite angle, the other one, 90 degree. So, the exterior angle theta 2 must be equal to theta 1 plus 90 degree. That is theta 2 equals theta 1 plus 90 degree, which implies tan theta 2 must be equal to tan of, applying tan on both sides, tan of theta 1 plus 90 degree, which implies tan theta 2 equals, this I am going to rearrange like this, 90 plus theta 1, which implies tan theta 2 equals, what is tan 90 plus theta? Tan 90 plus theta is cot theta, but cot theta 1. Here angle is theta 1. So tan 90 plus theta 1 is cot theta 1, but 90 plus theta 1 lies in the second quadrant and their tan is negative. Therefore, tan theta 2 equals minus, this cot can be written as 1 by tan theta 1 because tan and cot are reciprocal to each other, which implies what is tan theta 2? Tan theta 2 is the slope of the second line M2 equals minus 1 by tan theta 1 is the slope of the first line M1. Therefore, if two lines are perpendicular, if L1 is perpendicular to L2, then cross multiply get M1 into M2 equals minus 1. So, if two lines are perpendicular, the product of their slopes is minus 1, and if two lines are parallel, their slopes are equal. Thus, keep in memory these points. If two lines are parallel, their slopes are equal, and if two lines are perpendicular, the product of their slopes M1 into M2 equals minus 1. Very important question. Without using Pythagoras theorem, show that the points 4, 4, 3, 5 and -1 are the vertices of a right angled triangle. How to prove whether a triangle is a right angled triangle or not by using Pythagoras theorem is known for you. But in the question it is mentioned without using Pythagoras theorem. So, let A 4, 4, B 3, 5 and C -1 be the vertices of the given triangle. Using slopes, I am going to prove whether the triangle is right angled or not. Because you are known with the condition if two lines are perpendicular, the product of their slopes is -1. The application of this result, I am going to find the slope of the line AB. Slope of the line AB, let it be M1. The formula is slope of AB, y2 minus y1, y2 here it can be taken as x2, y2. So y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. which is equal to 5 minus 4 divided by x2 minus x1 is 3 minus 4. 5 minus 4 is 1 by 3 minus 4 is minus 1. So the net value is minus 1. Come with the slope of, I am going to find the slope of the line BC. Let it be M2. BC can be found out by using the formula y3 minus y2 by x3 minus x2. y3 minus y2 by x3 minus x2 equals y3 minus y2, that is minus 1 minus 5. Minus 1 minus 5 divided by x3 minus x2 minus 1 minus 3. Minus 1 minus 3 equals minus 6 by minus 4, which is 3 by 2. That is the slope of the second line. Now I am going to find the slope of AC. Slope of AC equals slope of AC. Let it be M3. Slope of AC can be found out by using y3 minus y1 by x3 minus x1. y3 minus y1 by x3 minus x1 equals minus 1 minus 4. Minus 1 minus 4 divided by x3 minus x1 minus 1 minus 4. Same value. Equals minus 5 by minus 5 equals plus 1. Therefore, we have m1 equal to minus 1, m2 equal to 3 by 2 and m3 equal to 1. But when m1 into m3 I multiplied, minus 1 into plus 1, the answer will be minus 1. m1 into m3 equal to minus 1 implies, what is m1? Slope of AB into what is m3? Slope of AC. Slope of AC. Slope of AB into slope of AC equals minus 1 into 1, that is minus 1, which implies if the product of the slopes is minus 1, then the lines are perpendicular. Therefore, the line AB is perpendicular to the line AC. AB is perpendicular to AC. Hence, the triangle will be, therefore, triangle ABC is right angled. Right angled. It is right angled at the point A. Come with another problem. Without using distance formula, show that the points minus 2, minus 1, 4, 0, 3, 3 and minus 3, 2 are the vertices of a parallelogram. You know how to use distance formula to show whether a quadrilateral is a parallelogram or not. Using distance formula, find the length of all the four sides. If the opposite sides are equal, then you can call it as a parallelogram. Here, you are asked to do the problem without using the distance formula. Let A, B, C, D be the given vertices. Let A minus 2 minus 1, B 4 0, C 3 3 and D minus 3 2 be the vertices of the given quadrilateral. AB perpendicular to A. We are going to find the slopes. Slope of the line AB I am going to find. For the line AB, you can find the slope by taking y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1 equals 0 minus minus 1 divided by 4 minus minus 2 equals 1 by 6. So the slope of the line AB equals 1 by 6. Now I am going to find the slope of the line BC. For the line BC, you can take the slope as y3 minus y2 by x3 minus x2. y3 minus y2 by x3 minus x2 equals 3 minus 0, 3 minus 0 by x3 minus x2, 3 minus 4 equals 3 by minus 1 equals minus 3. Now we can find the slope of DC. Slope of the line DC equals, for the line DC we can find the slope by using y4 minus y3 by x4 minus x3. y4 minus y3 by x4 minus x3 equals 2 minus 3 by x4 minus x3 minus 3 minus 3 minus 3 minus 3 equals minus 1 by minus 6, which is plus 1 by 6. Now the slope of dA also we can find. Slope of dA. Slope of dA equals y1 minus y4 by y1 minus y4 by x1 minus x4 equals minus 1 minus 2 minus 1 minus 2 by x1 minus x4, that is minus 2 minus minus 3 minus 2 minus minus 3 equals minus 3 divided by minus 2 plus 3 plus 1. So the value is minus 3. Thus you can see that the slope of AB and slope of DC are equal. In the same way, the slope of BC and the slope of DA are equal. Therefore, slope of AB equals slope of DC. If the slopes are equal, we can say that the lines are parallel. Therefore, AB parallel to DC. In the same way, the slope of BC equals slope of DA. Slope of BC equals slope of DA. Therefore, we can say that BC is parallel to DA. Thus, ABCD is a parallelogram. Why? Because opposite sides are parallel, then the figure will be a parallelogram. Next question. A line passes through x1, y1 and hk. If the slope of the line is m, show that k minus y1 equals m into h minus x1. Prove that question. A line passes through x1, y1 and hk. Consider a line L which passes through the points x1, y1 and hk. Given that the slope of the line is m, let L be a line which passes through the points x1, y1 and hk. If a line passes through two points, the slope of the line L, can be found out by using the formula. One can be taken as x1, y1 and the other can be taken as x2, y2. y2 minus y1, that is k minus y1 divided by x2 minus x1, h minus x1. This is the slope of the line by using a formula when 2 points are given for you. This you can take as x1, y1 and this can be taken as x2, y2. So the formula is y2 minus y1, that is k minus y1 divided by x2 minus x1. Take this as equation number 1. But if slope of the line is m, you are given that the slope is m. Given the slope of the line L equals m. That can be taken as equation number 2. From equations 1 and 2 we have. What we can write? K minus y1 divided by h minus x1 equal to the slope m. Cross multiply, get k minus y1 equal the slope m into, don't forget to put the bracket, h minus x1. Thus proved. Another question. A line through the points minus 2, 6 and 4, 8. A line through the points minus 2, 6 and 4, 8 is perpendicular to the line through the points 8, 12 and x 24. Given that the two lines are perpendicular, we are asked to find the value of x in the question. Let L1 be the line which passes through. L1 be the line which passes through. One line passes through the points minus 2, 6 and 4, 8. Minus 2, 6 and 4, 8. If L1 passes through the point minus 2, 6 and 4, 8, we can write the slope of the line L1. Slope of L1 equals, consider these 2 points, slope of L1 equals y2 minus y1, or you can write like this, like y1 minus y2, both are same. Y2 minus y1 by x2 minus x1. That is, I am going to take this way, 8 minus 6. 8 minus 6 by 8 minus 6 by x2 minus x1, 4 minus 2 equals 8 minus 6 is 2 by 4 plus 2 is 6, 2 by 6 which is 1 by 3. This is the slope of the line L1. Then, line through the points minus 2, 6 and 4, 8 is perpendicular to the line through the points these two. So, I am going to find the slope of this line. Let L2 be the line which passes through. L2 be the line which passes through. L2 be the line which passes through 8, 12 and x 24. 8, 12 and x 24. Here also 2 points, therefore we can find the slope of the line L2 equals y2 minus y1, that is 24 minus 12 divided by x2 minus x1, x minus 8. Here we can't simplify the denominator. 24 minus 12 is 12 divided by x minus 8. You are given that the two lines are perpendicular. Given L1 is perpendicular to L2. The line through this point is perpendicular to the line through the points 8, 12 and x 24. If L1 is perpendicular to L2, by the condition of the slope we can say, therefore, product of their slopes, the slope of L1 into slope of L2, the product of their slopes will be equal to minus 1. If two lines are perpendicular, the product of their slopes is minus 1, which implies we can multiply slope of L1 is 1 by 3 into slope of L2 is 12 divided by x minus 8 equals minus 1. Multiply again, which implies this 3 cancelling with the 12, you get 4 times. The remaining is 4 equals, or 4 by x minus 8 equals minus 1. 4 by x minus 8 equals minus 1, which implies 4 equals, cross multiply you get minus 1 into x minus 8, which implies 4 equals minus x plus 8. Therefore, x equals, minus x comes to the left side, becomes plus x, equals 8 minus 4. 8 minus 4 is 4. Therefore, the value of x equal to 4.